A single tweak in a tiny electrical parameter can make an industrial motor run perfectly, or burn out in seconds. Curious yet? That parameter is the V by F ratio, the unsung hero behind every variable frequency drive, or VFD. Did you know that this ratio is so critical that even a slight mismatch can triple your energy losses or cook your motor's windings? Stick around, because today we're diving deep into why the V by F ratio is kept constant in a VFD, its jaw-dropping significance, and what happens if it swings from 0 to 1. Let's get started. So, what's this V by F ratio all about? VFDs control the speed of AC motors by adjusting two things: voltage, V, and frequency, F. The V by F ratio is simply the voltage divided by the frequency, typically expressed in volts per hertz. For example, a 415-volt motor running at 50 hertz has a V by F ratio of 8.3 volts per hertz. Now, if we reduce the frequency to 25 hertz, we must also reduce the voltage to 207 volt to maintain the same ratio. Why? Because this keeps the motor's magnetic flux stable, preventing issues like overheating or torque loss. But here's the kicker: this ratio isn't random. It's tied to the physics of motor manufacturing. That's why a VFD always asks about motor parameters to enter while commissioning VFD for the first time. This V by F ratio tells how motors generate torque. Torque in an induction motor depends on the magnetic flux in its air gap, and that flux is proportional to voltage and inversely proportional to frequency. Too much flux and you waste energy saturating the core. Too little, and the motor stalls. The V by F ratio is the balancing act that keeps this flux just right. Now, why maintain this ratio constant? It's all about efficiency and performance. When a VFD lowers the frequency to slow a motor, it must also lower the voltage proportionally. Why? Because if the voltage stayed high while frequency dropped, the flux would spike, saturating the motor's iron core. That means heat, vibration, and wasted power, sometimes up to 20% more losses. On the flip side, if frequency increases but voltage doesn't, the flux drops and the motor loses torque. Think of a car engine sputtering at low RPMs. Take a look at this graph. A constant V by F ratio ensures the motor operates in its sweet spot across all speeds, delivering steady torque without overheating or stalling. This is why VFDs are game changers in industries like HVAC, pumps, and conveyors. But what if we throw caution to the wind and let the V by F ratio vary, say, from 0 to 1? Let's break it down. V by F, 0. This means zero voltage or infinite frequency. Either way, the motor's dead in the water. No voltage, no flux, no torque. The motor may stall under load or can lead to inefficient operation, especially in high inertia loads. It's like asking a car to run without fuel. V by F, constant, low voltage at a given frequency starves the flux. The motor weakens, torque plummets, and it might not even start under load. Imagine pushing a heavy cart with a feather. It's not happening. V by F, constant, high voltage at low frequency overexcites the motor. The core saturates, current spikes, and you get excessive heat, sometimes enough to melt insulation in minutes. So, why does this matter? The V by F ratio is the backbone of energy savings and precision control. In a VFD-driven fan, maintaining V by F cuts power consumption by up to 50% at lower speeds. In a crane, it ensures smooth, reliable lifting without jerky starts. Mess with V by F, and you're risking downtime, repairs, or worse, catastrophic failure. It's the silent guardian of modern automation. There are a few special cases where V by F ratio is slightly adjusted. 1 torque boost at low speeds. At very low speeds, motors require more torque. To compensate for voltage drops, VFDs sometimes provide a slight voltage boost. 2 field-oriented control, FOC. More advanced control techniques like FOC don't follow the traditional V by F rule, but instead control motor parameters dynamically for better performance. There you have it. The V by F ratio isn't just a number. It's the key to unlocking a motor's full potential while keeping it cool and efficient. Stray from that constant, and you're flirting with disaster. Thanks for watching this deep dive into VFD magic. If you found this intriguing, hit that like button, subscribe for more tech breakdowns, and let me know in the comments. What's the wildest motor fail you've ever seen? Until next time, keep exploring the science that powers our world.